I've been told by some that one of the things that they like about the Land Institute is that we don't just sit around in a barn thinking about things. We're actually doing something. And that something is developing a diverse perennial agroecosystem to feed humans in particular. And so what's going to happen next is you're going to hear from the brilliant people who are doing that. You're only going to hear from a couple of them because there are today so many of them that if you heard from all of them, and if they told you everything that they're doing, we would be here until midnight and Paul Winter would not be able to entertain us. So we're going to hear a selection from our chief scientist, Tim Cruz, who is also the director of our new international program, and from Aubrey Streit Krug, who is the director of the Ecosphere, there's that word again, studies program here at the Land Institute. And they'll give you a summary of generally what's going on. And then you're going to go back out onto the landscape, and you're going to touch and feel the work of the perennial future that's happening here in a real way. And you even get to taste some of it. So I hope you all got signed up for that experience after this. So I invite to the stage, who's first? Tim Cruz. Oh, is that right? Oh, you're all coming up. Okay, both of them, Tim and Aubrey.
Thank you all. We also will be joined by Allison Miller when she gets her food, wherever she is. If you're out there, Allison, I've got a chair for you up here. And we are actually going to ask you to think a little bit more for at least 14 minutes before we get into just listing some of the cool things that have happened in the last 3 years. But I do want to express just how wonderful it is to see you all here in this barn on the third day of fall, perched above the Smoky Hill River. It's just awesome. And as was the case in previous decades, as Rachel said, in previous Prairie festivals, Saturday afternoon is a time set aside for the researchers of the Land Institute to share with all you guests what we have been up to. Normally, this is not an easy assignment when we are trying to cover just 1 year as opposed to 3. And as many of you know, normally there are more than 3 people on this stage, Allison being here. That's because we're trying a new approach to the research review. Less time listening to us at the podium and more time interacting with the crew of ambitious and dedicated researchers outside in their natural habitat. There are both scheduled plot tours as well as program-specific stations that will be sprinkled across the TLI campus. And after the 3 of us offer some opening remarks, we'll provide a few more details on how this afternoon's program will actually work. So to kick off this research update, I'm going to start with the big picture, as some say about 30,000 feet. Then I'll make my way down to the ground, and then after that, Aubrey's going to take us underground. When I think of what has transpired since September 2019, all of the advances, setbacks, milestones, challenges, at its core, the work we're doing and the mission that motivates it have largely remained the same. But it doesn't really feel the same. And I've examined this feeling. I think that our world feels different because the context surrounding the work has changed considerably. COVID-19, the murders of George Floyd and Breonna Taylor, the rise of authoritarian actors and rampant disinformation, and the shift from climate change being likely to what is verging on scientific consensus that many extreme weather patterns we are experiencing today are directly tied to anthropogenic sources of greenhouse gases. Does this startling shift in context change how we think about the long-term work of developing perennial grain agroecosystems? It turns out you can't really answer this question without delving into a larger fundamental question. Under what circumstances would perennial grain agroecosystems contribute to the sustainability and coherency of human societies as well as natural systems. Or put another way, under what circumstances would perennial grain agriculture help reconcile the human economy with nature's economy? 2 books have recently been released, both written by authors I respect a great deal when it comes to thinking about the future. One is by Canadian geographer Václav Smil, maybe most famous for pointing out that about half of humans alive today owe their existence to the Haber-Bosch synthesis of nitrogen fertilizer, sort of a niche famous. Smil's latest book boasts the humble title, How the World Really Works. I'm not sure if anyone's characterized any of Smil's books as being uplifting. Honestly brutal, or brutally honest? I mean, it's a little slip. Yes, but not uplifting. That is, until his work is considered alongside this second book that looks into the future. And that is An Inconvenient Apocalypse, written by our own Wes Jackson, President Emeritus of the Land Institute, and Bob Jensen, Professor Emeritus at the University of Texas. Did I say Professor Emeritus? President Emeritus. In their accounts of the future, none of these authors think we can turn climate change around anytime soon. Smil, because we have profoundly underestimated how fundamentally and existentially dependent we are on 4 key fossil fuel-based pillars of society: cement, steel, ammonia, or nitrogen fertilizer, and plastic. All of which have gigantic carbon footprints, and none of which have adequate non-carbon-based substitutes. Jackson and Jensen agree with Smil's analysis. In part of Wes's art exhibition out here behind the barn here at the festival, these 4 pillars of society are on display. We might even refer to them as the 4 horses of the apocalypse. That's my wife Sarah's, not mine, or Wes. But Jackson and Jensen would not claim that it is the embeddedness of these 4 fossil fuel-based pillars of society that are to blame for our inability to turn climate change around. Rather, the 4 pillars are simply the latest manifestation of what might be called an evolutionary hangover, where the instinctual drive to appropriate carbon energy, drive that is shared by all animals, deeply curtails our ability to, in the words of Nancy Reagan, just say no to carbon. These 2 interpretations of why the human economy is discordant with nature's economy not surprisingly translate into different predictions about the future. Both involve pretty rough rapids ahead, and both think population will play an outsized role in where we end up. But Smil's forecast is decidedly open-ended, somewhat boring, and to some, very believable, at least for decades to come. Quoting Smil, Václav Smil, being agnostic about the distant future means being honest. We have to admit the limits of our understanding, approach all planetary challenges with humility, and recognize that advances, setbacks, and failures will all continue to be part of our evolution, and there can be no assurance of, however defined, ultimate success, no arrival at any singularity. But as long as we use our accumulated understanding with determination and perseverance, there will also not be an early end of days. The future will emerge from our accomplishments and failures, and while we might be clever and lucky enough to foresee some of its forms and features, the whole remains elusive when looking at just a generation ahead. In contrast to Smil, Jackson and Jensen convey a vision of the future with a little more certainty, and that is sooner or later, society based on high energy carbon will fall apart. The center cannot hold. There will be a decline in consumption of energy and the material existence it currently makes possible, and in parallel, a reduction in the scale of social groupings through which we organize our livelihoods. The human population is likely to reset itself at maybe 2 billion, down from nearly 8 right now, And the authors make it clear that we have no roadmap for navigating what's to come. They say, no individual, political movement, or government has a plan for transitioning from an unsustainable, high-energy, interdependent global society of nearly 8 billion people to low-energy societies with sustainable levels of population and consumption. I should say that I don't think the futures described in How the World Really Works and An Inconvenient Apocalypse are necessarily exclusive. But my read is that Smill believes that change is likely to happen more slowly, although a new pandemic could change that. And he would bet on humans having the capacity to ride the rapids of change with more of our social order and technology intact. Jackson and Jensen do not lay out a timetable, but one gets the sense that the rapids are around the corner and that we will be living in societies, once again, primarily based on sunlight, captured through photosynthesis of plants and accessed through food and fire. For me personally, I go back and forth between these crystal balls almost on a daily basis. The lens through which we envision the future influences all sorts of life decisions. But how about perennial polycultures? What about perennial polycultures? How do they fit in? What do they have to offer in these future scenarios? In Smill's future, there are a few features of a perennial agriculture, one that functions more like the prairie, that could help us back into the terms of nature's economy. For example, there's good evidence that perennial cropping systems, especially those involving mixtures with legumes, can help draw down atmospheric carbon dioxide by rebuilding the soil organic matter that was lost when the native perennial ecosystem was first converted to annual cropping. There's also evidence that perennial polycultures involving legumes can reduce the emissions of nitrous oxide, another very important greenhouse gas. In terms of adapting to the consequences of climate change, such as less frequent but more intense storms, work on grasslands has already shown that undisturbed soils covered with perennial vegetation facilitate greater water infiltration during intense storms compared to disturbed soils under annual crops. More of the soil volume gets filled with water, and the deep roots of perennial crops are able to access this stored water during dry times. The perennial crops greatly improve water quality by reducing erosion and leaching of nutrients. Perennials would reduce the number of tractor passes in a given field, as replanting every year would be a thing of the past. Indeed, the lives of farmers would be enhanced in a perennial future because the reductions in both workload and need for purchased inputs. In the gradual resource contracting future described by Smill, a natural systems-inspired agriculture would improve soils as a consequence of growing the crops, reduce the use of purchased inputs, reduce labor and fossil fuels required to grow grains, and would help with the adaptation to some of the climate challenges we know are becoming more common. In the future predicted by Jackson and Jensen, humanity in many ways will be hitting the reset button on culture and agriculture. And compared to the condition of the land 10,000 years ago, when humans first started growing grains, this new beginning will inherit croplands with relatively degraded soils, a flora featuring a sobering list of globalized noxious weeds, and climates featuring more intense erratic weather. Under these conditions, perennial polycultures that function more like the natural systems could make a profound difference in the lives of our descendants and the rest of nature. By protecting the soil from erosion, retaining nutrients tightly, building soil organic matter, infiltrating water, outcompeting weeds, and regrowing for years, perennial polycultures could provide a highly consequential and sustainable food energy foundation for civilization that would require far less human and animal labor than the annual crops that exist now. Regardless of the path or paths that humanity takes, whether our future lives resemble the lives we live today, while managing to adapt to tighter resource constraints through lower consumption coupled with technological innovation, or whether we experience a rapid shift that leaves most energy-demanding technological innovations behind as historic artifacts of the fossil fuel era, regardless of the paths humanity takes, I think it's safe to conclude that the journey will be better, and potentially a lot better, if we succeed in redesigning agriculture, our food-producing ecosystem, to function more like the highly diverse and highly perennial prairies, forests, savannas, tundra, and deserts that built the soils across virtually all landscapes on Earth in the first place. Whew. Thank you. That's okay. So I'm here to say that we're still feeling pretty good about this work. Okay? So what about it? Well, the rapidly shifting context of society and uncertainty about the future has made us rethink strategies and priorities going forward. For example, we don't want to place all of our eggs in one basket. The Land Institute is more than ever committed to involve research collaborators, not just across the US, but around the world, to participate in developing new perennial grain crops, improving the ones that are already being developed, and moving those crops from plants in research nurseries to energetically and economically viable polycultures in the landscape. Climate, political instability, and funding are examples of biophysical and social constraints that, if disrupted, could slow down or even end a perennial grain program. The odds that such a disruption would happen in any one particular place are not great, but the more research hubs undertaking this long-term work, the more likely progress will be made in one and will be safeguarded against the unexpected in another. The international program at the Land Institute is ramping up, as Rachel mentioned, and so keep your eyes open for exciting projects on that front. Another strategy we have embraced is giddy up. Now, speed and plant breeding don't tend to appear in the same sentence. And we honestly are not attempting to speed the development of perennial grain crops and cropping systems, but rather just progress a little less slowly. There are several ways to accelerate crop development, and we are pursuing them all. One, combine traditional plant breeding approaches based on traits that we can observe in the field and greenhouse with approaches that involve using plants' DNA to guide breeding decisions. Using molecular markers, genomic selection models, and other techniques so that we do not have to grow out plants only to find out that they don't have the traits we are after. Two, invite farmers, food product developers, and researchers to grow out our proto-crops even before they're ready. This is tricky because it can backfire. If early adopters have a bad experience trying to grow or make something from a proto-crop, that does not turn out well. But if people understand where a crop is in the breeding pipeline, then maybe they get interested in it and give it a try. This expands interest in the species and provides valuable information to the breeders, agronomists, and agroecologists working on the development of crops. And three, as mentioned before, inviting more researchers in North America and around the world to form hubs and participate in this research will build critical mass, resulting in more progress in less time. Something that has happened in the last 3 years within the US that has really helped expand collaborations with researchers at many universities and institutions is that the USDA has begun to take an interest in perennial grains. I remember listening to Wes talk at Prairie Festival, I think it was in 1996, in which he likened his efforts at getting government support out of DC for a natural systems agriculture to, does anyone remember? Kicking a 100-foot sponge. That was the name of the talk. I think the size of the sponge has gotten much smaller, and we are not the only ones kicking it. And some examples of what I'm talking about. In January 2021, the USDA published its U.S. Agriculture Innovation Strategy. And in that document was a list of ambitious goals, including deep-rooted perennial varieties are developed for all major row crops. There it was. It's like, really? Okay, so we'll take that. More recently, the Natural Resources and Conservation Service, or NRCS branch of the USDA, has made its policy that perennial grains can be grown on CRS extension lands, which are similar to the better-known CRP or Crop Reserve Program. And just last month, the NRCS released a request for grant proposals that include research on the integration of perennial grains into rotations. It's crazy. To our knowledge, this is the first time that perennial grains have been specifically included in any USDA grant program. But what has really spurred, this is a milestone. There is no question. We're worried about being appropriated or co-opted. We're worried about all of that. But it's also progress, and it cannot happen without resources being available to our colleagues to do this work as well. And I'll describe that right now. Something that has happened in the last 3 years within the, I've read that, okay. In January of 2021, I read that. And but what has really spurred greater collaborations is that several government programs have actually begun to award highly competitive grants to fund perennial grain research. These include several USDA programs, a program that is sort of a spin-off of the USDA called the Future of Food and Agriculture, or FFAR, and even the National Science Foundation. An exciting example of this support was announced in 2020 when a team of some 15 researchers, led by Jake Youngers at the University of Minnesota, was awarded a 5-year, $10 million grant from the USDA's Agriculture and Food Research Initiative. This project now involves 86 collaborators from universities, government agencies, nonprofit institutions, supply chain entities, farms, restaurants, and other organizations. The most recent collaborator on the project is Tomas Casani, a soil ecologist postdoc who arrived at the Land Institute from Argentina 5 days ago. And not only that, but Tomas's birthday is tomorrow, and I must give him his present, both volumes. I promise you. Allison Miller from Danforth, who's seated over there, she will move here in a moment. From Danforth and St. Louis University, we'll follow Aubrey with another version of how government funding can spur some amazing collaborations. So I guess I'm still hovering at about 5,000 feet with my treatment of research updates. All the crop improvement programs, perennial wheat and sorghum, silphium, sainfoin, Cura clover, and Kernsa, as well as all programs in ecological intensification, crop protection ecology, crop protection genetics, and soil ecology, and all of the programs such as Ecosphere studies and crop stewardship have their own stories to tell, and they will, out in the field after we disassemble here. So I want to close out my remarks by mentioning the work of our colleagues in the Yunnan province of China. Their perennial rice has in some regions now matched the yields of annual rice over 4 years, 2 harvests per year, and is being grown by 45,000 farmers. That's a new number. 45,000 farmers in the Yunnan province in China and a few other locations are growing perennial rice. Thanks to our crop protection ecologist, Ebony Morell, researchers at Louisiana State are working to bring perennial rice into the US for initial trials in the South. This introduction will take some years, but yet another indication that the perennial revolution is underway. So, as the Kansas motto goes, ad astra per aspera, to the stars through difficulty. With that, I want to bring up Aubrey Streit-Krug, who will bring us into the human side of a perennial future. So, Aubrey.
Friends and colleagues and collaborators and the folks here I have yet to meet, it's so good that you're here. Thank you for being here. It's good to be back, and it's good to be perennial. I'm going to begin my reflections and research update with a familiar assertion that roots are powerful. You might have seen the Land Institute's iconic Roots banner. It's hanging on the other side of that wall, if you want to go check it out here on the other side of the barn. It also hangs in the stairwell down to the seed vault over in the research building. It's been unfurled at stages, at presentations around the US and around the world. And I have heard the lore that Wes has rolled out the banner down the aisle of an airplane in the interest of public education and epiphanies. I wish I would have been there. The banner illuminates the roots of annual wheat and perennial intermediate wheatgrass. The depth and texture of those roots are contrasted on a plain black background. Removed from the context of the soil ecosphere, excavated from the tubes in which they were grown to be photographed for that particular image, these roots become accessible for observation. We can look at them up close, and we can step back and compare them to more familiar scales, like the scale of the human body, which is much shorter than those perennial roots. But what we can see is simply the start of understanding the power of roots. In that portrait of plant roots, we can just see that snapshot in time. But we can stretch beyond a single moment and beyond sight alone to sense a greater reality. Plant roots are not static. They are not simply moments in time alone. They are living time. They seek energy and water and nutrients. They exchange, they invest, they pull up, they push down, they tense and release, they rub up against and compete, and brace and infiltrate, and they decay and turn over. They take different forms for different plants and in response to different plant communities and ecological context. So as you think again of the roots banner in your mind's eye, or as you close your eyes and contemplate this prairie landscape in which we're embedded, I ask you, can you sense this rooting movement of matter and energy? It happens below ground in the dark, but it is integral to how sunlight powers the life of the ecosphere. I want to suggest that we humans are as in the dark as roots. We stand above them on top of the ground, and we can bask in the sun, unlike those roots, but our lives are interdependent with them and interdependent with so much that we can't see. We are in the dark when it comes to knowing much about the future, too. What we do know is our powerful propensity for seeking, making, learning. Humans are not pictured in that banner, but we have shaped and are shaping the annual and perennial grain crops whose leaves and seeds and roots are depicted. We humans observe, select, tend, harvest, process, eat, trade, store, plant, and replant. Human hands, technology, and labor, not to mention other animals and tools, are woven into the movement of matter and energy across generations and landscapes. And along the way, roots have become more than material. They have become metaphorical. It's perhaps common sense in this crowd to know that the word radical grows from the Latin word for roots. But I'd like to name something even more basic, that in English, words have roots. We say they have roots. That's a conceptual metaphor, which is a building block of our thought. We, speaking English, think of words and language as having come from somewhere, and roots are how we talk about that connection to place. Roots are how we trace relationship. So roots are evocative. They evoke human communities, our origins, our genealogies, our family trees, our interdependence on each other. They evoke getting to the root of the problem, which is an analytical approach that perceives problems spatially in terms of depth, something that you can get at. They evoke the phrase putting down roots, colonizing places by uprooting others in order to put down one's own roots. And also, I hope, creatively committing to places by repairing and making anew the roots of belonging. So roots evoke dynamic and moving patterns of thought and behavior and interaction, the patterns by which we make meaning and determine boundaries, the patterns that comprise culture and society. So can you sense those rooting movements of humans, our peril and our possibility? I wanted to share this reading and kind of rereading of the Roots banner for a couple of reasons. First, to investigate why roots are powerful. It's not enough to just simply assert that fact. If roots are to be transformative, if we want to make and be new roots, per the theme of this Prairie Festival, per the theme of New Roots for Agriculture so many decades ago, we have to open toward the whole reality of roots. What they are, what they can mean. We have to open for conversation and interrogation and collaboration. We need to open and are opening to generous critique as a form of care. Second, I want to provide this reading of the Roots banner to invite you into a shared experience of the kind of research themes and activities that I'm going to describe next. Research is intellectual and rational and driven by data, and it's also embodied and emotional and carried by stories. That's because humans are the ones who do research, and we are all of those things and more. As long as we live and eat, we humans are always in culture, in social and economic relationship, in the material and energetic context of the ecosphere. To recognize and reckon with this reality is the start of how we search and research together to create a perennial future. I appreciate and want to echo Tim's reflections on this changing ecospheric context and the ways in which that urgently changing context both does and doesn't change our long-term work, both emphasizing and calibrating our understanding of the value of diverse perennial grain agricultures that nourish more just human communities within ecological limits. And for my part, I'd like to reflect on how this changing ecospheric context has shaped our research strategy in terms of culture and society and economics and education. The deepening and accelerating ecospheric emergency has influenced the kinds of questions that we ask. For the last several years, we've been investigating if the ecological future of grain agriculture is to be diverse and perennial, what is required of us now in social terms? I think it's a pretty compelling question still, and asking this question has led us to really probe some of the basics of what and why and when. What needs to happen and why and when? We posit that human agricultures and cultures need to be grounded in the ecosphere within more than human ecological and energetic limits and built on fundamental human social values. And this transformation towards increased responsibility and decreased fossil fuel use needs to happen now for communities to endure in our home planet. You have heard and will hear more about this really basic, crucial knowledge through the festival, and you can explore it more in various books and articles and podcasts and videos developed by our Land Institute researchers and collaborators, including folks like Stan Cox and Wes Jackson and Bill Vitek, which have common themes but different and plural perspectives. We will certainly keep inquiring into and building our basic knowledge of our ecospheric context. And what we know now prompts us to ask and frame new questions. Not just what and why and when, but who and where and how. If we know something about what needs to happen, how do we pursue it? So in Ecosphere studies, we continue to evolve our research and educational efforts, as I'll share more about in a moment, and to grow our team and network of collaborators. And the question that we're leaning into investigating is, how do we bring courage to the movement to change patterns of meaning and norms and values and behaviors so that human communities can realize these more just perennial cultures of agriculture and learn to live within ecospheric limits. In crop stewardship, led by my colleague Tessa Peters, we have grown a new program that works with Kernsa and all of the proto-perennial grains that we're developing. I hope you'll enjoy meeting and eating some of these perennial grains soon, this afternoon, if you haven't already at the pancake feed this morning. And I want to name that back in 2019 at our last Prairie Festival, we just had a commercialization manager, and we now have this growing crop stewardship research team that investigates the question, How do we steward the movement of crops from research stations onto the landscape, supporting innovative and sustainable supply chains in which perennial grains are adopted, valued, and consumed? I'm magnetized by these how questions because they're practical. They bring home what is at stake here and always. How we research, how we relate, how we live now may matter for if and how a perennial future becomes possible. How the World Really Works, the title of the book Tim mentioned by Václav Smil. How the World Really Works is a statement of scientific knowledge, including our contemporary petroculture's reliance on fossil fuels, and I also believe our enduring social interdependence and reliance on care work. How could the world really work is a question of moral imagination that invites us to apply our knowledge of reality toward the common good, or toward what Omar and I have written about as a social perennial vision. So based on these how questions, I've come to perceive our collective research strategy as translational. We aim to bridge the gap between what we know or think we know and what we do. We translate knowledge into testable questions and practices that benefit humans. The knowledge that we translate, test, and apply comes from across scholarly disciplines and practices in the arts and humanities and social sciences and natural sciences. It also comes from engagement and collaboration outside of and beyond scholarly disciplines. So our research methods are increasingly what's known as transdisciplinary. To name a few of these, we're testing civic science as a method for advancing new crop domestication. How do you make new crop domestication happen in more resilient and quick ways? Something we're very interested in. So in this 2022 growing season, more than 120 civic scientists around the US are collecting data, connecting in their diverse local places, and sharing their stories of growing and caring for future perennial grains. They're collaborating with us to study the perenniality of our perennial wheat line and to conserve the genetic diversity of Silphium ecotypes. Several of these civic scientists are here today. I met one in the middle of the dance floor last night. I'm so excited that they're here, and I hope you'll come meet them over at our civic science booth along with our civic science research technician, Anna Anderson. Over the coming year, we're laying the groundwork for our largest civic science learning community yet, with a focus on accessibility, diversity, and inclusion. Our transdisciplinary research also involves exploring how to adapt perennial grain cropping systems for different regions and contexts, in close collaboration with farmers and other partners. Over the past 3 years, the crop stewardship team approved licenses for more than 130 Kernsa growers, nearly a 10-fold increase. That's scaling up at an appropriate pace, and the team is also interested in scaling deep. This year marks Sophia Skelly's transition to a new role in crop stewardship as our Upper Midwest Hub Coordinator, based in a region with a large number of perennial grain supply chain stakeholders, several of whom are with us here today. Here at the Land Institute's headquarters and home hub in the central Great Plains, community engaged research involves building capacity through a new position that we've recently opened the search for, a land relations coordinator. This role will focus on initiating and stewarding relationships and projects that help realize a more just and perennial future in this region. So they may help us to learn to live into our responsibilities to this land, including our Marty Bender Nature Area, to the indigenous nations whose homelands in which we're located, to partners in this region like the Kansas Black Farmers Association, and to the diverse human and non-human communities here. These emerging efforts point to the importance of who is involved and included, and the recognition that where research takes place can matter for resilience in a rapidly shifting context. The who and where and how of research also matters for legitimacy. We basically know, going back to that basic knowledge, that robust or thick legitimacy is a requirement for a diverse perennial grain agriculture to be realized at scales that make a meaningful difference. We've also been taught through writings by Mewa Montenegro DeWitt and others in the field of agroecology in which we work, that legitimacy is ethical, political, and highly integrative. It's a result of both scientific and social efforts that's tested in both scientific and social terms. Transdisciplinary research in which knowledge is produced through collaboration may be a way to build legitimacy. but if and how such research builds consent, trust, equity, and justice is of great and primary interest. So in this regard, oh, thanks. I agree. In this regard, I want to highlight a new collaborator in our work, sociologist Amy Teller. She's based at the University of Minnesota. Amy is studying social sustainability in novel Kernsa supply chains in Minnesota and Kansas. And since there is not a standard definition or understanding of what social sustainability is, that involves first really asking growers and partners, how do you understand and envision the social benefits of perennial grain crops? It might be found at the nexus between what these folks want to see sustained in their communities and what they want to see changed and how. Amy, along with researchers from our group at the Land Institute, applied their knowledge to create race and equity activities at this year's Kernsa conference and have contributed to the development and the implementation of a race and equity framework for the Kernsa USDA CAP grant that Tim mentioned earlier. And through that same grant, we've been engaged in another activity in crop stewardship, which advances our understanding and collaborations. We've been working on strategic planning for the creation of a Kernsa Stewards Alliance. This is led by the crop stewardship and commercialization efforts, in which actors along the supply chain work together to take on responsibility. They're using a steward ownership framework in which stakeholders can be centered in decision-making and hold power, and in which the purpose, vision, values, and market opportunities for Kernsa can be stewarded. We're really excited for the KSA to emerge. Also in development and beta testing right now are a growing suite of educational lessons for high school and undergraduate students that situate the story of Kernsa within its larger social, agroecological, and ecospheric context, and that spark discovery on topics from plant breeding to supply chains to visioning a perennial future. This curriculum is called Kernsa in Context. I hope you'll check out some of the materials and activities at the booth organized by our post-baccalaureate researchers, Lydia Nicholson and Claire Weinman. And I hope when you look at the roots banner, at those intermediate wheatgrass roots that help power the production of Kernsa perennial grain, you join with me in curiosity about the evolutionary and social ecological history and future of this plant species, about where the roots of intermediate wheatgrass have come from in Eurasia and where the new roots might repair degraded land here and around the world. I want to close by mentioning that thanks to a collaborator's recommendation, I recently read a book by Gal Beckerman titled The Quiet Before, on the unexpected origins of radical ideas. It's about how social and cultural change of all kinds starts, and early on in the book, Beckerman writes, and I quote, "If we rewind to the instant when a solid block of shared reality is first cracked, it's usually a group of people talking." So I invite you to think about roots with the power to crack concrete. I invite you to consider roots with the power to search into and hold on to soil and each other. I invite you to contemplate how we might be and become those new roots. Let's keep talking. Thanks.
So now we're going to hear a little bit from Allison Miller, again from the Danforth Center in St. Louis University, who's a close colleague and good friend. Allison.
Thanks, Tim. Thanks. Good afternoon, everybody. It is such an honor to be back here at the stage at the Land Institute. Thank you for the invitation. I have 5 minutes, so this will be very brief. I'll start by saying the projects that I'm discussing today are the work of many people here at the Land Institute and in St. Louis, people who are working with us today and those who have come before. We carry everyone with us forward in our work, and we're just so grateful for the opportunity to contribute to this perennial revolution. 2 exciting projects have cropped up in the last 3 years that involve collaborations between the Land Institute, the Danforth Center, and other partners that I'll mention. First, Tim and also Aubrey talked about the need to make less slow the process of developing new perennial grain crops. And we're doing this using a modern twist on an old idea. It's the idea of early stage selection. Can we tell from a seed or a seedling or a germination rate or a spectral signature that comes off that seedling what that individual plant might do in the field? We're testing this idea in 3 species that are near and dear to the heart of the Land Institute: intermediate wheatgrass, sainfoin, and Silphium integrifolium. So the way this works is that we comprehensively phenotype or collect data on the features of the early life stages of those species at an individual level. We use this using automated approaches and more standard ones. We do it under regular treatments and a drought treatment. And then we take those individual plants, which are barcoded. We put half of them in our field sites in St. Louis and the other half here in Salina, and we monitor them over the course of 3 years to see if, in fact, any of the traits that we measured early on in the life cycle are predictive of what we later see in the field, particularly aspects of yield and root growth. That's a project that's funded by the FFAR public-private partnership that Tim mentioned. Our hope is that information will be used by breeders to try to speed up this domestication pipeline. The second project focuses on a broader ecological question, which is how do the physical attributes of plants, both above and below ground, how do they influence the plant communities around them and the soil ecosphere? And we're interested in this question from 2 perspectives. The one that I just mentioned: can individual plant traits enact changes in their communities around them and in the soil? But also, how do the soil and the plant communities affect those traits? So just over 1 year ago, we launched the New Roots for Restoration Biology Integration Institute, of which the Land Institute is a critical part and really provided the intellectual foundation for this initiative. This is a 5-year, $12.5 million grant from the National Science Foundation that includes not only the Danforth Plant Science Center and St. Louis University, my home institutions, the Missouri Botanical Garden, the Land Institute, the Chicago Botanical Garden, University of Kansas, University of Missouri, and the University of Vermont. I hope I'm not forgetting anybody. The Institute brings together researchers from different disciplines, so plant organismal systems biology, population and community ecology, and the soil ecosphere, and others that are working in restoration ecology, and really tries to build a bridge across this major theme, what is one of the major challenges of our day. Land use conversion, including both urbanization and agriculture based on annual plant monocultures, has impacted 75% of lands globally and has contributed to the loss of half of the world's topsoil in the last 150 years. So the core research activities of the New Roots for Restoration Biological Integration Institute focus on this overarching question: can we restore critical ecosystem functions to our degraded lands and our agricultural landscapes? And can we use information about plant traits and the effects of those traits on plant communities and the soil to improve restoration efforts, both in degraded natural systems and also in our reimagined agricultural systems like those that are being developed here at the Land Institute? So our hope is that in order to advance restoration, this New Roots for Restoration Institute will ultimately, through 10 different research projects that I'm not going to explain in this 5-minute window, will improve prediction of below-ground functional traits based on above-ground phenotypes. We hope it will accelerate the selection of robust perennial ecotypes for use in restored wild landscapes, as well as breeding perennial crops like intermediate wheatgrass and alfalfa, among others, for use in reimagined agricultural ecosystems that mimic the prairie in their diversity and perenniality. So I'll sum up by saying it's been an incredible pendulum swing, I would say, in terms of research activities and application of various technologies and approaches to really bring this perennial dream into all different sorts of reality. And I'm so thrilled to be a part of it. I'm so glad that you're all here, and I'm so grateful to the Land Institute for leading the charge. So thank you.